Hello everyone, this time I will give you a way to how to solve Schrodinger equation logically. Let's start. Let's see Schrodinger equation in initial value problem. Initial value problem means the initial value is given, and this is Schrodinger equation in cat representation. Let's see overview of strategy. We'll use Hamiltonian basis denoted by E alpha cat, and assume that Hamiltonian doesn't explicitly have time, and we'll generalize in dependent case later. And let's see our assumption. We assume that eigenvalue of Hamiltonian is continuous, denoted by, obviously this is energy, and each eigenspace respect to energy is degenerate, denoted by alpha. So this is the meaning of this cat vector. And we typically use basis to solve vector problem, right? So we can rewrite cat equation like vector and matrix equation. And because of Hamiltonian operator has matrix representation like this diagonal matrix, right? So this equation is just a number of first order equation. And after we solve a number of first order equation, we can reunion all of these components, then we can get a real solution. So solution of Schrodinger equation is just sum of normal modes. Normal modes means physically every system is oscillation in one frequency, and this is just component of each row, right? So, but we assume that this is in Hamiltonian basis, right? And we don't know anything about Hamiltonian basis because the problem isn't given for me. So solve Schrodinger equation means solve eigenvalue problem of Hamiltonian. Because after we solve eigenvalue problem of Hamiltonian, we can apply these steps, so we can solve Schrodinger equation generally, right? So solve Schrodinger equation means solve eigenvalue problem of Hamiltonian. And some books call this time independent Schrodinger equation. This is same ultimately, right? And we can see another feature of Schrodinger equation. Solution is unique. This is very important feature because first order ordinary equation has unique solution. And let's see rigorously. We can write this state cat like this. This is completeness of Hilbert space and Hamiltonian operator, right? Because Hamiltonian operator, Hermitian operator. And in some I'll tell you some detail. This alpha notation must inside integral, because each alpha is depends on energy, right? And we can rewrite as this because we have orthogonality of Hermitian operator, and that is in this case Hamiltonian operator. So we can write this cat as this, and let's apply this Schrodinger equation. Then we can get this equation. And when we solve vector equation, we just compare components, right? So if we compare components, then we get first order equation because only time differentiation is in here, right? So this is first order equation like our overview, and we get each component solution. And if we reunion, we get this. This is solution of Schrodinger equation. And we can rewrite this part unitary operator. And physicists say this unitary operator propagator because it looks like propagating initial state vector to state vector in some time t. We can get very important features of Schrodinger equation solution. Once normalized, stayed normalized, even if Hamiltonian depends on time. This is very important feature, right? We don't have to normalize state vector anytime. Once if we normalize in initial state, because we can write Schrodinger equation solution like this using propagator, right? And we can write this propagator as this, and this is obviously unitary, right? But this notation is valid if this operation is converged, and we have to check operand 2 whether converge or not. If converge, this is very useful notation because we know that unitary, right? It looks like rotation initial state vector, right? In linear algebra, we already know that rotation is also unitary. So in my textbook, they say it's rotation. Anyway, there are many ways to solve Schrodinger equation because solution is unique. This is most important point. We don't matter. It don't matter to how to solve. The important is Schrodinger equation solution is unique. In Griffith's textbook, they use separation by parts, right? Or separation variable to solve equation. Anyway, this is one of the very useful because this is very simple to write, right? But this is more complex to solve real solution. A real solution to use. This is it has advantage and advertise obviously. But if we use this notation, we can simply get this is unitary operator, and the norm of state vector is given by this, and we know unitary operator conserve norm or inner product or orthonormal basis. We already studied in linear algebra, right? So this is same as initial norm. So this is proof. It's done. And I'll tell you something more. Even if Hamiltonian depends on time, it doesn't matter because we can divide time into very infinity small time denoted by delta, and in this delta interval we can regard Schrodinger Hamiltonian as a constant like linear approximation. So we can get state vector as composition of unitary operator, right? Like this is k minus 1 u2 u1 psi 0. This infinitely many, but we can regard as this. So Hamiltonian, even if Hamiltonian depends on time, it doesn't matter. Our state vector can be normalized. We don't have to effort to normalize this. And we also get Schrodinger equation solution is unique even if Hamiltonian depends on time in the same manner, right? Thank you for listening my video. Good job.